When you tell people that you're a radio astronomer, they often have no idea what you mean. They know what a radio is, but maybe they get astronomy confused with astrology, and they come to the conclusion that you deliver horoscopes over the radio. This is not, in fact, what radio astronomers do. Radio astronomers use telescopes like this, or arrays of radio telescopes like this. They point it at the sky, and they collect light, which is in a very specific part of the electromagnetic spectrum. This part right at the end here with the long wavelengths. For reference, you see that little narrow strip of visible light? That's what your eye is capable of seeing. But to look elsewhere, so to look in the radio, for example, you need to use telescopes. So we take our radio telescopes, we point them to the night sky, and we see this. This is what the sky looks like in the radio. Now you might look at this and think, oh yeah, I see. This is basically what the sky looks like normally, right? All the little dots are stars. And I'll stop you, and I'll say, no, you're wrong. Every single one of those dots is a radio galaxy. None of those are stars. Those blotches to the left are supernova remnants, and those big whiter blotches up here are clouds of ionized gas. So I've already made one of my points, that looking in the radio opens a window to an otherwise invisible universe. Another example. This is an optical image of the M81 group, a group of galaxies in the Big Dipper. This is the same image in the radio. You get more information. The radio image tells you more than just where the stars are. It tells you where the neutral atomic hydrogen gas is, which is correlated to where the stars are, but which shows you that the galaxies are actually interacting with each other, which is a fact that you totally miss in the optical. Another example, this is an optical image of Centaurus A, a sort of ordinary-looking elliptical galaxy. But when you look in the radio, you see that there is this feature that's totally invisible in the optical. This galaxy has huge radio lobes that are being emitted from the supermassive black hole at its center. Each of those little dots that I showed you in that picture of the radio sky is one of these radio galaxies. This is another radio image. You might have seen it before. It's the microwave cosmic background radiation, which is radiation that was emitted right after the Big Bang in its aftermath when things were beginning to cool down. It's in the radio because as the universe expanded, so did that radiation. So the radiation went to longer and longer wavelengths, and longer wavelengths is in the radio end of the spectrum. Being able to see this has totally revolutionized cosmology. It's enabled cosmologists to learn more about the early universe, learn about how the universe has evolved, learn about dark matter, and it's in the radio. So radio is the best. Another reason to observe in the radio, Earth's atmosphere actually absorbs most of the radiation coming from space, most of the electromagnetic spectrum. So you see here, those lines that are so up at the top, that means full absorption. That light doesn't get to us at all. There are only two windows. One is in the visible, that very narrow window there, and one is in the radio, that huge window over here. Bigger window means bigger range of wavelengths, means bigger range of sources. Third, there's a technique that's unique to radio astronomy called interferometry, which allows us to get very high resolution of what we're looking at. Basically, you take a bunch of different telescopes, 27 telescopes in this case, you put them in one array, you point them all at the same object, so you're looking at that object from a bunch of different angles, and you combine that information, all those different perspectives, to make one high-resolution image. You could even put those telescopes across the whole North American continent, put one in Hawaii, put one in the Virgin Islands, and get what is called the Very Long Baseline Array, which has the resolution ability to read a newspaper in Los Angeles from New York. So, a quick recap of why radio astronomy is awesome. It gives you access to this otherwise invisible universe. It enables you to perform ground-based observing, which is a lot cheaper and more convenient for astronomers. And it allows you to get ridiculously high resolution on things like the structure of galaxies using the technique called interferometry. Basically, radio astronomy is a lot more than this.